Hello and welcome to the lab on the breadboard. This laboratory is going to be one of the easiest ones you do all semester. However, it's going to be one of the most important because it will involve the principle by which we make connections in electrical circuits while avoiding the use of complex equipment such as a soldering iron. This device over here is called a breadboard, and it's called a breadboard because its appearance sort of looks like bread because of all the holes. The pattern of holes has been carefully labeled. You'll notice columns labeled A through J and rows numbered 1 through 30. And the idea behind this breadboard is that when you want to make connections between two things, for example, this red wire, which I have just placed in A7, and this blue wire, which I'm going to place in B7 because I know those two are connected, that will allow us to establish whatever electrical circuit is necessary for our current lab. Today's lab involves deducing the pattern of all connections on the breadboard. And in order to do that, we're going to be using our IOLab device to serve both as a source of voltages, you'll notice here labeled as 3.3, and as a measurement of voltages where it has 3 inputs labeled A7, A8, and A9. For this lab, we're going to be using A7. And to understand the principle of how this works, I'm going to take one of these wires and I'm going to attach it both to the 3.3 input as well as to A7. And when I start the IOLab software recording A7, I'll be able to go in and out of this contact and then observe what happens on the screen as I do so as an indication of whether I have or have not connected the 3.3 volt to A7. Here's my IOLab device window, and I'm going to select to measure input known as analog 7, after which I'll be able to press the record button. Currently, I have the lead out, and you'll notice that when I'm not connected, I measure about 1.5 volts, which is half the battery voltage. When I connect the lead in, it jumps to about 3.3 volts, out, in, out, in, and this will allow you to use your IOLab as a visual indicator of whether you have indeed made a connection between the 3.3 volt and the A7 input. Now that we've established how to determine whether or not we have made the connection between 3.3 and A7, we're going to place 2 wires, one in the 3.3 volt and the other one in A7, and then use the breadboard to attempt to make our contact. For the first exercise, I'm going to take the 3.3 volt wire and I'm going to put it anywhere in this column that's labeled plus on the left-hand side. And then I'm going to take my A7 wire, which in my case happens to be red. The color of the wire is actually irrelevant. And I'm simply going to poke around on the breadboard for the purpose of finding out who is and who is not connected to the current hole that I'm using. After you've determined all of the connections along this so-called positive power rail on the left, you will repeat this for the negative power rail on the left, the positive power rail on the right, and the negative power rail on the right, and then proceed to use random points throughout the middle section of the breadboard so as to determine who is connected to which other. Now, it is not necessary that you actually try every combination of pairs of holes. That would be ludicrous and it would take too long. Instead, what you need to do is use your intelligence to be able to decide which pairs of holes are and which pairs of holes are not connected to one another. And in order to document this in your laboratory report, what you'll need to do is find a picture of this breadboard, either taken with your own cell phone or perhaps on the web, and then add to that image a collection of lines which indicate which holes are and which holes are not connected to one another as determined by both your experimental knowledge and your common sense. Good luck.